I'm just looking at, I'm still in week 11. I didn't move those out. These assignments still live in week 11 that we want to finish from week 11, group two, worksheet and drawing. So I'm going to preview a little bit. So that's what we're going to jump into today. For you guys, what's going to be helpful is this week, the only one I have posted so far, but I will add at least two others after this. Because really what we need to get through is this base mount Rev 1 I'm calling. And then we do a guide block that I haven't loaded and an offset stop. I have them on my board in my classroom. I haven't loaded them yet here. So we've at least got two more assignments to load for this week in pictorial isometric drawing. But what I want to show you is the first one off the bat. You're gonna have to. This is what I like about this. I did a little redesign on this homework assignment because it's going to make you go back through your own files and find this assignment. So this is your, because I'll probably be jumping in this in the second half of tomorrow on Tuesday. So this gives you a day to get ahead on this thing. Base mount, you've already drawn the base mount, but it goes back to week 6. So if I'm going to open this real quick and just preview this, give yourself a little time to find this stuff for you. So base mount Rev 1 is going to be a revision from this base mount drawing that looks like this. This drawing was one that was an assignment from week 6 that I gave you the model and you guys dimensioned it. Then we went over it, and then I probably graded this already and gave you back the feedback from what some people fixed their drawings pretty quickly and re-uploaded them after we went over the key and I posted the key. The key's posted for it. So essentially what it requires on your end is to get back in this drawing, make sure that it's correct. And it would look like this. It could look a number of different ways. You would really want to go back to your week 6 feedback for this base mount drawing and open it back up and make sure that you've made the corrections, or just review the revisions that I probably either gave you, or make sure that you've corrected this assignment, because you're going to use it as your base for this particular. What we're going to do is we're going to add the isometric view of this. And so originally, yeah, and so what we're trying to do is not only are we adding the isometric view, but we're also adding the new template that is the ISU template. Because when we drew this, we were on our own title block template. We're going to bring this into the ISU template and bring your drawing, which doesn't mean you have to redraw this whatsoever. I mean, if you've lost it, yes, you're going to have to redraw it. And it's not a crazy complicated one, but if you have it, it would be best to work with what you have and bring it in. And so when I get into this assignment, so in order to get ready for tomorrow, I would want you to find this assignment and at least take care of the red lines for the dimensioning and then have it saved and ready to go. I'm just gonna show you a few little things on how to just bring the ISU template into that drawing, put everything on the ISU title block page, draw the isometric view of it, and then put that in the drawing as well. And then I'm going to do a batch plot, which is just when you have multiple sheets in a drawing. We haven't done this much, maybe, and the architectural students may have done this a lot because a lot of their drawings were just batch plotted PDFs, I'm thinking. I don't know. But if you have multiple drawing sheets, just how to print them off so they're in one PDF is what we'd want to do. So there's a little bit of this assignment incorporates, yes, drawing in 2D in 3D looking object in 2D. It has that component. It also has just doing a revision from one drawing to the next, so bring it up to date. And then it has an element of just knowing how to maybe do batch plots on the printing. So it's a little bit of a technical aspect and drawing aspect, but maybe just what I feel like is it's a little bit of drawing management and then actually doing some of the new drawing. So we'll probably start this second half of class tomorrow. So in the meantime, find this thing. It's from week 6 for sure. My files are organized by weeks. You choose to organize however you want. But in my course, I have mine all organized by week. So if I went to week 6, knowing that's a week 6, it's this base mount is where I have mine. And then my ortho key look like this is what yours should end up looking like once it was done. And so this is the drawing you'd want to find, and which has where I drew this. And really, it was a drawing that you downloaded from Canvas because you added the dimensions to it, and then you re-uploaded it. So obviously the original drawing still lives in week 6 assignment. You could pull it, it's just not dimensioned. and then you could dimension it. So there's ways to get back to square one by tomorrow, but this is where you'd want to be because I'm just going to go in here and add the isometric to it. And then mine, probably like yours, my template had both sheets. I think when I did the assignment, I turned it in as probably on an A size sheet because it looks like I've strategically placed this thing to fit on an A size sheet at a 1-to-1 scale. I have the B size sheet, but I don't think I used it. I put it in the layout, but it's also at a 1-to-1 scale. But we're going to bring in, yeah, I'll show you tomorrow how to bring that in and bring in the new template just from this file. I'll probably save it as a new file. It'll become a Rev 1 of this drawing. So we're just going to try to bring it in and finish this drawing. So that's my plan for tomorrow. So look for that thing or redraw it if you have to, but I hope you don't have to redraw it. Okay. Because that's a matter of you keeping track of your own files, which is super important. So this is a lesson in that. If you have to redraw it, it's a lesson in I should keep track of my files better. So I have it. Okay. And then you should have like made the revisions to this. If you didn't dimension it quite right, and then I gave you feedback, you could pull up that feedback, or you could look at the key and get it dimensioned. Just notice maybe what you did differently than I did. Make sure things are sized and located right. Okay. So moving on from there, that'll be tomorrow. That's a preview of tomorrow. No charge. Today, let's do this other assignment. So let me put back out. The other two that we'll do this week, they're brand new drawings. So this is the only one that we have like a revision going on this week, which I like. I'd like to do more of that kind of work, but I only have this one that I've modified to be that way. So right now we're going to jump into worksheet and Fastener Group 2, and I'll do the same way I did Group 1. I'll work the worksheet and the drawing kind of simultaneous. So I'm kind of working on both these assignments at the same time. So um, the worksheet should just be a Word doc, probably a download. There's the doc there to download. So I'm going to open up mine. I should have a blank slate that is, that's the key. I'm going to move that over here. Let's do the other one, this one. So worksheet 2 should look like this for Fastener Group 2. Really, it's a key way. We're doing pretty simplified views in this, but the kind of 4 different objects going on here, but I call it kind of almost 3 different ones. We've got a hub, they call it a collar here, and a shaft. So this is kind of a hole and shaft relationship going on. And so there's some tolerancing that's going to go on here. So it has A is going to be, yeah, let me read this. Calculate the required size of the square key needed for a 2¼ inch ID collar. So we have a 2¼ inch ID collar, or we'd call it a hub, maybe. I think in the index that we need or the appendix we need to solve for this, they might call it a hub. Essentially, it's the hole for the shaft to fit into. And then we need to ASME standard dimension that. So we got to kind of revisit that. We've done that one other time at least, maybe ratchet plate a couple times. Geneva Cam had some ASME. They were kind of the hub. And we dimensioned that key, the key way in the hub, a pretty particular way for ASME standard. We'll do that again. And then we need to actually do the other size or we need the other side of that is the shaft itself going into this hub and calculate the required size of the square key needed to match the shaft for the collar or the hub. And we're just drawing simple front views of those. We're not going to draw a right, even though we have no depth. We don't know how long the shaft is. We don't know how long the hub or collar is. That's okay. We're just going to do them as front views and how they fit together and kind of the tolerances that would be associated with those in order to make them fit together. So that's kind of A and B. I kind of consider that's just one thing. They work together. So we'll do that one probably first. Then C, we're going to have to do this where we take our fastener and we actually put it to work. So last week we just drew fasteners that they weren't doing anything. We just kind of just drew the fastener themselves. Here's one that's going to be in some work. It looks like we've got some aluminum we're going into, an X and a Y plate. So do 2 different plates. Like I'm using this fastener likely to hold plate X in position in relation to this base Y or whatever this is here. So we're going to do this ourselves here. This kind of the simplified view. The trick here is just kind of like thinking about how a fastener fits into a hole. This isn't a through hole. This is what we'd call a blind hole, meaning that in this particular part, maybe those threads had to be cut to accept our fastener. Those so internal threads were cut into this Y part, and so we'll get to that one. It looks more complex, I think, than it is, but I have to reference the same maybe sheet from that we were using last week, the same appendix for some of that. I think it's in order to do this, I think I've added on some stuff to that appendix that'll help us solve that. This stuff comes out of a different appendix, by the way, so I'll show where that is. And then we have this one that just is a little standalone. One more, it could have been thrown on the other ones, but it's not. A little standalone set screw fastener. And so we'll talk about what that does and why it is the way it is when we get to that one. So I view this as kind of just three different things. I know there's four different things we're drawing, but okay. And then they give us the local note for that set screw, a square head set screw with a full dog point, and they give us our local note, so we'll know how to maybe dimension that. But it's got some similarities to how we did that hex head in a way. So yeah. What? Oh, so here's my. This is my. Oh yeah, I think. Yeah, got it. Okay. So my worksheet starts with an example that's been done, and so I'll walk through the example and how to use the worksheet, and then we'll do that for our actual size one. So I think I preloaded the sizing from the A and B question here. I sure can. Let's do that. Thanks for asking. I forget that sometimes. And it's buried here somewhere right there. Got it. Back up. Go back to my worksheet that's up here, right? I think it's this one. Yeah, so let's see how even, so what it says here is that in order to do this Fastener Group 2 worksheet, I need to find the thread bolt handout with graphics, okay? That one just, that one I pulled up, it's just to know I don't think this one is critical to pull up. I don't think, but we can look. It's in here. So this is the assignment. We're gonna fill out this worksheet. Let me go back out to the main hub of the assignment for week 11 here. Remember, I loaded a bunch of resources into the resources for this week just because they kind of apply to different assignments. So let me open this up. These are going to be where I should find the handouts that it's directing me towards. So the first one it said is the thread terms handouts. I mean, I'll open this up. I have my copy on my thumb drive here. Let me find it. Week 11. Thread bolt handouts with graphics. It looks like this. I don't think we need this too much for this particular. I mean, these were some instructional sheets on how to draw this. So I know I allude that I need this. But I probably need this when it comes closer to this doing the problem C of the group more than, and maybe the dog point a little bit is captured on here too. I think it probably is, but I think it's in Appendix B as well. So I think the necessary stuff that I need is probably pulled in onto Appendix B. So this one I may or may not need, even though it says the thread bolt handout with graphics. That's what I just pulled up. It's not my, but I do need this one, key seat dimensioning, and the Appendix B. So I think that I call this key seat dimensioning. Let me look in the resources tab. Key seat dimensioning handout. So we haven't used this last week. This will be the first time using this particular resource, this PDF. So I have it as my key seat dimensioning resource. This PDF, I'll open it up. It looks like this. First page is just a bunch of instructions. It's actually the instructions on how I filled out my example one on my worksheet, or my example on that worksheet. I'm following this tutorial here, or these instructional sheets. So how to obtain the proper dimensions for a key seat. What we're actually referencing when we do this is the machinery's handbook. This is the machinist Bible. That is this huge, thick thing that is a lot of it has a lot of stuff in it, machining related. There are some sections of it for key seats, shaft, and like keyway combinations. So even if we had called out what's going on here on our print, like the machinist is probably going to go and double check your work as a drafter and as an engineer ahead of you. The machinist is probably going to go back and make sure that the print that you're providing them makes sense to their own the machinery's handbook. And I don't know when the 27th edition came out, but that's what this is saying. We have some excerpts from it. So if I scroll down to the next page, page 2, these are excerpts from this Bible. And I do think this is page number. So this would be on page 2363. So what I mean is it's a fairly all inclusive volume of mechanical stuff. 2364. Yeah, so we're pretty deep into the into the machinery's handbook at this. But it is a very like I mean it's a thick volume of information. So these are just some particular ones that have been pulled out for keys and key seats. So this is like a little bit of a research project that we and then we're gonna end up with a drawing that somewhat looks like this, only I'm gonna put it on my ISU template. So it's not gonna look like this anymore. I think this last page was maybe how it used to finish off, but we're gonna bring it into the ISU template. So I could in the future like get rid of this because I don't even I'm not even I will come back and check to make sure I dimension mine the same way, but I'm not even going to use this as my go-to dimensioning yet. Uh maybe I don't know if I've posted imagery for this yet. I should look. But so what I've got open is I've got that. I've got my key seat dimensioning handout. I don't really think I'm going to need to use the thread terms handouts, but I do have it open in case. And I'll need Appendix B when I get to some other stuff, but not for these first couple, and especially for the first hub and keyway here that I'm going to do, or hub and shaft. So I'm going to bounce back out to the main page. Now I'm going to go look at so I've got the worksheet up. I've got to kind of look through it and understand how to use it, but I'm going to go to the drawing and talk about, and let's see what I posted up for the drawing here. I thought I posted some imagery of what it looks like. So we're going to use our ASME inch template. We'll figure out which scale, which sheet it fits on the best. We'll probably tabular notate this potentially, or I say that using the concepts of tabular notation annotation, which is I built a table for worksheet or group 1. I don't think I built a table for this one though, so it's this is maybe a little misleading. I don't have to do it tabular. I do mine as more of a local note scenario here. So I didn't build a table. I use local notes to call out the fasteners, their thread notes, and so this is also a simplified way. A table's great when I have a lot going on and I have a lot of different fasteners, and maybe they're always better captured in a table. This is a case where I just have a couple of fasteners, and so this is kind of the direction I'm headed for my drawing is to fit them all on one. They don't all have to fit in the same viewport, so I can do different viewports of them, but I'm going to try to fit them all, and they don't have to be arranged this way on my drawing either. However I can fit them is going to be great. Probably a B size sheet will be the most beneficial, but. So I'll probably draw them with enough. I can't remember if I had them in one viewport or not, but this is kind of where we're headed. So, and I think it tells me I'm going to have to use, it doesn't really tell me, just that I'm going to have to use that Fastener Group 2 worksheet and have it filled out to even be able to draw. So let's start filling that thing out. Okay. Love these worksheets. Love them. Love them. Let's just look through how I got the answers for example 1. And so I might split screen this with my handout that is which one? It is this one. The machinery, the keyway dimensioning PDF. So I'll just kind of look over this with you here a little bit. They just use a 1-inch nominal diameter shaft. So the first thing they say is we're just going to do an example with a 1-inch nominal diameter shaft. So that's why I've put the hub inside ID is 1 inch here. We're going to find the dimensions for the key seats for both the shaft and the hub, like a keyway or a key seat. The key seat might be the correct term for the one in the shaft. It's like the seat. You might make a little area of the shaft to accept a key. The keyway is, I think, the more correct term for the hub, or what they call the collar in that. So that's a keyway and a key seat, but they're kind of interchangeable. But maybe I think of keyway as being both of them, but technically in the shaft, it's a key seat. Okay. 1 inch is given. Use a square key stock and a class one fit. Okay. So we've talked about different classifications. There's probably different classifications. This is alluding to there's different classifications for the way keyways and key seats kind of fit together with their keys. Because it really is a three-part combination going on. Not only do we have the keyway and the key seat, but we also have the key itself that's going to fit in and lock these three pieces together. So I think in the finished drawing, I think I don't draw the key itself though, right? I just have the key seat and I have the keyway, but I really am not drawing the key, but it would be the third component to this whole assembly. So, and every time I do this, it'll be a little bit of a pain, it looks like, to get my other piece back. This one, I don't know, right there. Okay, so I'm going to refer to table one. Based on the nominal shaft diameter of 1 inch, we select a 1/4 inch. So they decided just based off the diameter of the shaft, we should be able to say that there's a 1/4 inch key. So I'm gonna and then I'm gonna go look at this step one and see how they determined that it was a 1/4 inch. I have that listed. The nominal key square is a square, meaning it is a square key, quarter by quarter, because there are rectangular keys depending on what the machinery handbook kicks me out. So this is like a square key. It's 1/4 inch by 1/4 inch. Let's see where they pulled that out. It says it's from table one. So I'm going to go down here. Here's table one. We sure do. You sure do. It's in, yeah, it's in the resources for week 11. Yeah, we resources for week 11. Yep. Key seat dimensioning handout. That's the one you're going to have. That's the one that I have open on my split screen. Split screen sadness. That's a song. Yeah, that's what I'm using here. I'm down to table one. Really, my worksheet's filled out with the example from this first page here. So it's a 1 inch nominal uh shaft. I think they're kind of driving that size by the shaft diameter they're saying is 1 inch. So and I show both. The inside hub is the outside of the shaft. So hub has the whole size, shaft is the outer diameter. They're both 1 inch. The outside diameter, this is kind of maybe not necessary, but in order to draw it, you would need to know like how thick is the hub. So that's 2 1/4. Anyway, don't get that mixed up with this 2 1/4 over here. So they just gave us that maybe, or maybe I made that up. It felt like I needed that and I have it on my other work or something, but I don't know. Maybe it's something that I find. But what I want to do is I'm on to table one here to look for just and how I use this table. Maybe I'll zoom in a little bit here. Looks like we have some definitions going on oh yeah, and it said class one fit. Here it briefly kind of hides what these classifications might be. So I haven't read all this, but this is an ANSI standard key and key seats. Looks like we have a bunch of tables to look through. We have some key definitions, key seat, class one, class two, class three. So it said it's a class one fit. So a clearance or metal to metal side fit obtained by using bar stock keys and key seat tolerances as given in table four. This is a relatively free fit and applies to only to parallel keys. Okay, so that might not make total sense to us, but it would to a machinist. Um, we can have a class two or class three fit, possible interference in a class two. Okay, relatively tight fit. Class three is an interference side fit and is not tabulated in table four. Since the degree of interference has not been standardized, however, it suggests the top and bottom fit range, blah, blah, blah. So this is made to be a kind of a force fit. So ours is a free fit, or it should be relatively free fit, minimal clearance, but there should be clearance, probably a clearance type fit. So I shouldn't have to force fit this at all for a class one. Okay. So we'll just see where that comes into play on this at all. But what we would say is to even use table one, we just want to find out where our shaft fits in table one. And it's going to be similar to fastener. It's going to be like under to over, or you just got to watch, they're given by ranges. So the nominal shaft diameter is given by ranges, and over and to and including is what that would be. It would include this size. In order to use this particular row, I would have to make sure that my shaft size is over this listed size and at least to and including this size. So it's kind of the way, it's like that greater than and less than scenario. Mine is a 1 inch shaft, so I just need to, I think I'm on the row where it actually fits right here because mine's bigger than 7/8, but it's less than inch and a quarter. It could include inch and a quarter, but mine doesn't. Mine's just 1 inch. So I'm really on the fourth row down here for this data. What it tells me though, okay, great. That's where my shaft size fits. It's 1 inch, it fits in here. The width means the width W. I probably need like a picture to go with this. I don't know if they give it to me here, but this is the nominal key size. They probably don't give me a picture. I have to visualize this a little bit. I think there are some pictures in this chart, but it's saying that they call width W, and it is a the nominal key size. Nominal meaning kind of that uh, kind of a basic size, or but not the actual size, right? The nominal key size is what I'm going to base. It's because there's going to be some tolerances associated with this. So they call it nominal because I'm gonna actually have to, in order for these things to fit together and have clearance, then I'm gonna have to probably tolerance them in order for that to happen. And so they're saying the nominal key size height is going to be 1/4 inch. If it was rectangular, it'd be 3/16, but we're going to do a square size fit. So it's going to be a width 1/4 by 1/4 is the key size. That's how they're pulling this 1/4 inch right here is off this where it lines up here. But if it was calling for a rectangular key, then it would be 1/4 by 3/16. So ours is, I guess, I thought I couldn't remember how this chart was, but I guess I'm saying call it a 1/4 inch square here, or sorry, call it a square key. And I think I'm going to do the same thing for this one that we're actually going to do. So on the example one, we're going to call it a 1/4 by 1/4. And then the normal key seat depth is going to be, for the square key, is going to be 5/32. I would have actually have 1/8 right here. I don't know if I have a column on my for that particularly. I don't think I do. So I know I'm not saying I'm pulling this data in yet, but however, this is my row. So I'll come back to that. That's step one. I feel like I've understood now how they got step one. Step two, and we're going to go on to table two. This is where you find the nominal dimensions S and T. So they just have these two variables. They call one S is the maximum allowed, and T dimension is the minimum allowed. So they're kind of like a min max. So they're going to give me a minimum maximum like width and depth for my key way and key seat so that the key will fit in it. And so if I have a nominal key, if I have this key that measures 1/4 by 1/4, I just want to make sure that my key way and my key seat will accept that and they won't interfere with that for a class one fit. Okay. So I'm going to have to understand what's going on with this S and T variable. They say they pulled that the S dimension is 0.859. So I've added that to my chart. And the T dimension is 1.114. So I need to understand like how they got those. They're going to be found on table two. So let's look at table two. Table two looks like this. Key and key seats. And I think this is just leftover literature they're talking about from this page here. Key size, shaft diameters. They've got a lot of instructions here. It's probably good information. I'm just going to look at pictures here. Go down to table two. Here it shows me S. Okay, S is the dimension. It's kind of the seat depth, and we likely it's a dimension that ASME likes to they like their key seats dimension that way. Let me double check that real quick and see on my example here. Snap back out to my little cheat sheet here. Let's see if I use, yeah, see, I've used an S dimension there. It's this key seat dimension. ASME likes this. Mine's toleranced because there probably is a variance that this can be. So, and I think the T dimension is this one. And ASME likes us to dimension our keyways this way. So let's go back to that. Let's go back to this. So S and T are going to end up being finished dimensions for sure on my drawing. So it would have to, it's driven also by the nominal shaft diameter. So in the example, it's 1. And so it says if it's, and then of course it's breaking down columns of whether these are square or rectangular keys and whether I'm talking about shafts or I'm talking about hubs or I'm talking about tapered hubs. So I believe ours is a parallel hub. That just means that the whole through, because I have no depth given on my example. If it's a taper hub, there would be some tapering to that depth actually, and it would fall into kind of a different category of for sure on the hub. It would definitely impact that. Ours is a parallel, which just means that we're hoping that our shaft is a nice, true cylindrical shaped part, and it's going to go through this hole in this hub or this collar that is also straight and true and cylindrical shape. Parallel. That's what they mean by parallel. It's like the through hole or the shaft itself are nice and true. So I think of parallel is kind of confusing. I think of the word cylindrical maybe makes more sense. They're truly cylindrical. So okay, that's when they mean parallel. And taper means the hub or the shaft may be tapered for that kind of a fit. Tapered shaft, taper hub. Maybe a parallel shaft, but a tapered hub on it. Okay. Definitely different fits for sure. But mine is a 1 inch. And so this is where they're pulling that dimension. It just is flat given that the S dimension for my seat should be 0.859. So that's what they put here, 0.859. 859. And then I can skip over the rectangular because mine's square. And then to the hub, it's 1.114. So they're saying that T dimension is 1.114. So they didn't have to do any calculations. They just pulled it off the chart. Great. That's cool. 114. And then mine's not tapered, so I don't even have to worry about this tapered column. So great. That's step 2. Let's go back up here and let's see what they call step 3. Now we got to go down to table 4. So the upper portion of this table is class 1 fits. That's what we want to do. The top half of the class 1 fit is for square keys. We need to find the depth tolerance for both the shaft key seat and the hub key seat. Or I think of key way, key seat, and key way. So these tolerances will be applied to those S and T dimensions from table 2. And since our key is a 1/4 inch square, we'll use the over to and including. So I think table 4 is driven by the key size. I would have had to know what the key size is. And then I get this like tolerance. I'm going to build this tolerance from my nominal dimensions from table 2. So it's kind of table 1, then table 2, and then table 4 is going to help us build the tolerance we need to fit this 1/4 inch square key. So I've got to drive my dimensions by the key from table 4, and then I'm going to get these different dimensions and see how that affects my actual kind of a nominal dimension given here for the S and T. Okay, so we'll see if we can make sense out of this. I know it gives you a lot more literature to read, but I'm going to fast track it. And let's see if we get this. So what I ended up going to here is that I end up with like from that table, I must be able to pull out the tolerance for the key seat. That's on the shaft. And the keyway in the hub, I should be pulling out a tolerance from table 4 as well. And then once I apply those tolerances to these dimensions, this kind of goes back to our tolerancing worksheets. Once I this is kind of like that, where I pull those tolerance allowance from that sheet, table 4, that's on this one. And then I will like do the math associated with these like nominal sizes here. And I'll be able to get kind of a range. I'll get a range of what my S and T dimensions can be, and that'll allow me to kind of build a dimension style when I go to dimension that'll cover that. So let's see how we do that. So let's go back here. I think we're only on step 3, right? And then step 4, we might come back. Yeah, so let's go to step 3, table 4. You guys love these sheets, I know. Oh, hopefully there's a table 4. Right there. Table 4. So it's really driven by that left column. Sorry, that leftmost column is the type of key. Ours is square. And like they said, they've got 2 different tables. They kind of split them here. One is for a class 1 fit, and these other ones are class 2 fits, which are really a tighter tolerance, almost on the verge of interference type fits. So we're looking for a class 1 fit, square. And this is the key width though. So I have to know my key width. I'm not driven by shaft. Don't go to the 1 inch here. Go to 1/4 inch. So I've got to find the range where my key fits here, right? So this is key width. This is over to including 1/2 inch. This would be over 1/2 inch key, including 3/4 key. So mine actually fits on the first row. Mine is like, I mean, they almost start with like 0 to 1/2 inch is essentially what's going on here, but mine is a 1/4 inch. It fits in this row. So what I'm going to look at is what these class of fits are. We've got a side fit or a top and bottom fit. I can't remember what it said on ours here, but we've got key seat, fit range. Okay, key seat. So let's see where I've pulled these dimensions off of here. I think I'll go back and read a little bit more. I know where I'm at. I know I'm on row one here. Let me see what data I'm pulling off here, though. Let me see if it gives me a little bit more information in the, we know that we found we need to find the depth tolerance for both the shaft key seat and the hub key seat. These tolerances will be applied to those dimensions. The S dimension for shaft key seat cannot be the nominal value of that. Okay. Let me go down and see. I can't remember if we're pulling. I can't remember which one I'm pulling here, or if it's maybe obvious to me. Let's see. I was just looking at what their little disclaimers are here. We've got the little footnote A, limits of variation, CL, clearance, INT is interference. So CL here is meaning clearance fit. We've got key and key seat. Yeah, and we're talking about the key. This is the key width and the key depth. Ours is 1/4 inch both. Ours is a square key. So um, the key width. So let's see on mine what I mentioned. So I say the depth tolerant shaft key seat is this depth tolerance shaft key seat. So I've kind of built my what I'm looking at. I haven't looked at my worksheet for a little while to determine, but I did build my row of my worksheet to try to match at least their columns here because I feel like this was confusing a little bit. So definitely, if you're just following my worksheet, might be the best way. Look for the depth tolerance on the shaft key seat. So here's depth tolerance. And I guess they call this side fit. And if you think about this, the reason why they might be calling this as a side fit and a top and bottom fit is if we just go, let me go up and just like look at their imagery they put on this one. So this might be the that doesn't show great for sure, but we're definitely thinking of when we dimension this out, the side width to like width would be associated with this side to side fit, and the depth or top to bottom fit would be this way, if that makes sense. So that it can be confusing looking at their chart saying what the heck do they mean side fit versus top and bottom fit. Well, it's just the difference between like a width, the key width and how we tolerance for the width and the top and bottom, right? And how it fits up and down. So I think to make a little bit of sense out of that for anybody that might be confused is that's I thought they might have a picture of it better, but mine has a better picture actually. So maybe I guess if you included this one. But yeah, so essentially what we're looking at is these columns. We're talking about the key width kind of, and then we're talking about the key depth here. So mine just starts with the key depth for no reason. I just put it in this order. The depth tolerance shaft key. So I'm looking to see what that tolerance is on my particular row for the shaft key seat. I say it cannot be any bigger than 1/4 inch, but it could be smaller than a 1/4 inch by this much because we're talking, these are tolerances with the key itself, right? This is key tolerance. Yeah, so that's why I've added +0 and minus 15 thousandths is how I would call this. And so that is the tolerance on the key. The 1/4 inch key cannot be any bigger than a 1/4 inch, but it can be 15 thousandths less than a 1/4 inch in its top to bottom or kind of the height dimension of the key. Okay, that's great. I understand that now. How about the depth tolerance for the hub keyway? Because that's the shaft. So the hub depth tolerance is this one right here. It means that my hub itself can be oversized by 10 thousandths plus 10 thousandths, but it can't be undersized at all. And that if you think about the relationship of those two, that definitely makes it a clearance fit. You know, the hub can be a little bit bigger. That's the keyway cut in the hub. It can be a little bit bigger than a 1/4 inch by 10 thousandths, but it can't be any less. And the anyway, yeah, for the key itself. Okay. I guess I shouldn't maybe I misspoke a little bit because I am still thinking about the 1/4 inch key in general. So I'm thinking about yeah, okay. Okay. Let me not over talk and confuse anybody of that. But I've pulled that out of this column here. 10 thousandths over, none less. That's what I've got. That's how I built this. Now I've got to apply those tolerances to the correct one to the one they go with here. So it's like, okay, so that means if I've picked out these tolerances, shaft S with tolerance applied. So S is this from that one chart, 0.859. with the tolerance applied for the shaft, I want to know what the range becomes. And so it becomes this. It means I can't be any bigger than 8.59. And so I'm just 8.59, 0.859. But I can be under 15,000. So I take 0.859, bring up my calculator here, right? I would say I'm sorry, I always say 8.59, but 0.859. And I'm going to subtract 15 thousandths, right? 0.015. So I get that my hub, or sorry, this is my shaft. My shaft with my tolerance applied gives me a range that my the S distance or that depth in my actual shaft can be 0.859 to 0.844. That's the shaft with the tolerance applied. I think it's confusing to even go through the example. Maybe it'll be easier when I'm working with my fresh numbers here, but then I've got the hub T just because the variable for T, the variable for the hub is T. And so that was this on my hub, 1.114. The hub tolerance I got was it could be bigger by 10 thousandths, but no less. So I added 10 thousandths to that dimension because the given dimension was 1.114. I can add 10 thousandths, that's 0.010. So my T with my tolerance applied is 1.124, but it can be no less then. So it's then 1.114. So that is this is the way this is how I'm going to build my dimension for my actual. So when I see these, it's like, well, what are these? Well, these are actually the dimensions here, right? If I look at this little cheat sheet here, that's how I was able to come up with these dimensions, is applying those tolerances essentially. Okay, we'll get to that point though. We just got to keep filling out our worksheet here for a minute. We got to start again and do our own row here. Great. So then the tolerance and key seat hub. Okay, width tolerance. So the width tolerance is back to this row here on our 1/4 inch key. It says the width tolerance for the key or for the hub. Which is not real clear here. Because I call it the key seat. Oh, I do call it key seat. Okay, great. The key seat in the hub is going to be this particular tolerance set, plus 2 thousandths, minus none, plus 2, minus none. If I apply that shaft and hub key seat width and tolerance applied, it's a 1/4 inch, and I can add 2 thousandths to that. So it can be 1/4 inch to 0.252 is the shaft and hub key seat. Okay. Let's see how that works out now. That's confusing. Yes. Let's see if we can do it ourselves though. For our actual dimensions given, I don't know, could be hard. We just start with step 1 and the table 1 stuff, then step 2, table 2, and then step 3 would be table 4. Yes, I guess finishing the last 2 here is still referring to table 4. We now look up the width tolerance for the key seat. This width will be the same for the key seat in both the shaft and hub. That's why there's only one. It kind of applies to both shaft and hub on the width. And that's how we got those dimensions, was following that one particular column. Might be confusing on why we followed that one. We'll get to it. Let's see what we can get here. Let's try to do one from scratch here. Okay. It looks like I've already done. It looks like I guess when I uploaded this, I didn't realize that I've already given you guys some answers. Probably, yeah, I already gave you guys half the answer. Half of it I've already done for you. That's good. So if I go to my example now, which is from the beginning here, you have to know this. Calculate the required size for the square key needed for a 2 1/4 inch ID, collar or hub. And then we're going to draw those, and then calculate the required size for the square key needed to match for the actual key seat here. So okay. So essentially, I'm kind of working both these in A and B column here. So it's a 2 1/4 inch hub, or the shaft is going to be 2 1/4 inch. They're going to match as their nominal size, that is. Okay. So I'm going to go down to my table one, and it looks like I've already, yeah, like I said, I've already done the first few answers. Let's just make sure. I'm going to double check my work here and make sure I did it right. So it says I need a half-inch key. Let's just make sure that's correct. And I should have deleted these, so you had to do it. But 2.25 is the shaft diameter. So this table one is driven by shaft diameter first. So great. Well, I need to find where 2.25 fits on here. That's 2 1/4. So 2 1/4 to 2 3/4. That's a row that might work. The only problem is 2 1/4 to 2 3/4 means that I have to be over 2 1/4 inch on my shaft size, and I'm not. My nominal size for my shaft is 2 1/4. So I'm not going to use this row. This has to be over 2 1/4. I'm going to use this row. This is including up to and including 2 1/4. So this is my row. Yes, this is my row to determine what my key size is for my square key is a half-inch. It's given right here. So that's how I've pulled the first data in. It's got a half-inch key. Great. Half-inch. And then what's the shaft S and or yeah, what's the shaft S max dimension and the hub T max? All right, let's look at table two for I'm still driven by the shaft diameter here on this table. For a square, I'm looking for the S, which is the shaft max dimension it can be. Clear to almost the bottom, huh? 2 1/4 right there. So this is my nominal shaft diameter, 2 1/4. Here is my S value, 1.972. So I should have included that. Yep, 1.972 is my this particular dimension, max. It's just that I'm not going to dimension that on my print that because I'm gonna have to allow some tolerance for that. Whether it's plus or minus, I don't know, but yeah. So that's going to be a critical dimension, but it's not going to be the exact dimension because there's going to be some tolerance around that dimension. So hub T now is the other one I need for the same row. So I'm not doing rectangular. I'm going to do square right there. So I say that it should be 2.477. Yep, 2.477 is my is the T max dimension that will be. Yeah. Okay. So I've got those two populated. I do agree. This is the correct information. Now I got to figure out what this is here. So the depth tolerance shaft key seat. So that's on table 4, right there. I'm looking for the depth tolerance for the shaft key seat. So this is in the shaft. Depth tolerance, shaft. It's kind of a top and bottom fit that we're talking, up and down. For the key size now, right? Key size is half-inch. So I'm looking for 1/2 inch. This is over and up to and including. So it's actually the same row that I was really using for my 1/4 inch key. So it's really going to be these are going to be the same data from here essentially. So because they fall under the same kind of key, the tolerancing is the same from a 1/4 inch key to a half-inch key essentially. So if I go over here, it's going to be for the shaft is going to be plus none and minus 15 thousandths. So technically I could just like copy this. Control copy. It's the same tolerance for this half-inch key. I guess what's confusing is I'm going to apply the tolerance to this is the shaft key seat, right? And I'm going to apply this tolerance to how I cut the key seat in the in the actual shaft. So even though these are driven by the size of the key, it's not that I'm cutting the key down. I want to make that clear. I'm not applying these tolerances to the size of the key. I'm applying the tolerances to the shaft that the key goes into. But I'm using the key to drive that tolerance. I'm like, well, if my key is this big, I need this much tolerance like machined into my shaft and into my hub to fit this key into it. Otherwise, it's not going to fit. And so that's why they're going to allow me to say, you know, hopefully that's going to make sense out of these dimensions when I go to actually tolerance them. But that's how I pulled that one in. And it should be the same here again, I think, for the depth on the hub keyway. The depth on the hub. I call it the keyway. They call it a key seat still. I kind of feel like, and this is the machinist Bible, so they should know. But I feel like this is key seat and this is maybe keyway, but all right. And I think your theory book kind of talks about that, but it's going to be the same. It's plus 10 thousandths minus none, plus 10 thousandths minus none. So it ends up being the same as the quarter-inch key. So I'm going to copy that and paste it over here. Perfect. And then I just got to apply. These will be different numbers, of course, because my nominal sizes are different. So now what I'm going to look at is the shaft S with the tolerance applied. So here is shaft S. I'm going to pull up my calculator here. This is just calculator work. So the shaft, this depth that I'll allow it to vary is going to be minus none. Oh, sorry, plus none and minus 15 thousandths. So shaft S, that's one. So let me clear this out and do my nominal size on my shaft is 1.972. And I just need to apply these tolerances. So really it says for the shaft can be no bigger than this. So I'm going to say it's going to, so I'll just say it'll start with that dimension there. It's going to be, if I apply the, how big a tolerance, that's plus none. So it's still going to say 1.972. And the range is going to be, this isn't a subtraction, this is a range. 1.972 to 15 thousandths under, right? So I'm going to take 1.972 over here, and I'm going to subtract 15 thousandths from it. This is going to give me kind of a range for the shaft S, or the depth, 1.957 is my range for my shaft. What helps me think of that is this picture here. This is the shaft. That means the S dimension, it can't be any bigger. I'm going to zoom in on this because I just feel like this kind of makes sense, that if I'm going to put a key in here, and I'm just talking, the only dimension I've even dealt with here is this depth dimension here. I haven't even talked about the width yet, just the depth. So this S dimension in a shaft, it's telling me, this tolerance is telling me it cannot be any bigger than what's given, this, but it can be less than that, 15 thousandths, because I want to make room for the key. I wouldn't want it to be any bigger than that. Otherwise, the key won't fit and the hub key shaft relationship will not fit. So I'm actually saying it can never be bigger than 1.972, but it could be smaller, because that would make it, if that makes sense to you, that means this dimension would be less, 15 thousandths less. And so really it would be cutting a deeper seat in this is what it would be. I mean, that's kind of bad. I mean, it's kind of weird thinking. You have to visual. To me, it helps to look at that picture and be like, what is this? What does this tolerance even mean? It means that I have to make room for that key, never be bigger than this. This dimension can never be bigger than 1.972, but it can be less than that, 15,000. So my key will fit in there good. It'd be like cutting a deeper groove, deeper key seat in that shaft is what's going on there. Okay, cool. We'll look at the same thing with the hub, because the next thing is the hub with the tolerance applied. And so here's the hub nominal, 2.477, which you have to kind of think of like, sorry, you have to think of this dimension. When we're talking about the hub, we're talking about its kind of overall dimension depth wise. We're still only talking about depth. These tolerances are only the depth tolerances. Great. So the hub one here is 2.477. Here is my hub tolerance. It can be bigger than that by 10 thousandths, but it can be no less than this. So I think I wrote this like with the big size first, but to me, it doesn't matter as long as you know which one's which. But so the big size first is it's telling me it can be bigger by 10 thousandths from that. So if I pull up my calculator and I say, oh yeah, this is a 2.477 nominal hub T size, right? The overall with the hub diameter plus the keyway cut into it is that. And I can be bigger than that by 10 thousandths plus 0.10 is 10 thousandths. And so I get that this hub could be as big as 2.487, and then it can go down to some dimension, but it tells me it cannot be any less than that. So it's going to be 2.477. That's how I apply this tolerance to this dimension. Essentially, that's all I'm doing. Applying this tolerance to this dimension for the keyway, for the shaft and the key seat. And I'm applying this tolerance to this dimension for the hub and the keyway. Now, if I look at this picture to help me better understand that, maybe it does. and I look at this number here, or look at this tolerance, it says that this T dimension then, it can be bigger by 10 thousandths, which is me cutting a bigger, it's me cutting a bigger keyway in by 10 thousandths. But it can be no less than that. Otherwise, the key will not, a half-inch key will not slide in. So essentially, if I look at this real close and I say, if I hit my S in kind of its maximum material condition, and I hit my T and it's like least material condition, that will allow, that'll be the tightest fit for that key. I mean, it'll almost be like size on size. It'll be like a half-inch can barely fit in there. And so it would still fit, but it might still be kind of hard to get the key in there. It's going to be better if I probably, if my machinist cuts this to allow some of that tolerance, they'll know that it'll, they will know that it will fit in there better. So yeah, hopefully that makes sense. It's always confusing. Some people have had some experience with this stuff and it makes sense like this. Some people are like, what are we talking about? I'm like, I get it. Be patient with yourself. And we're about there with the dimensions we need, but we've only really talked about the depth. S and T are just the depths. And so when we look at our chart here, we've only been talking about kind of that top and bottom fit or that depth. So really we need to calculate the width element. So that's just going to be the width. The key has a width as well. It's a half-inch key. It's square, half-inch wide by half-inch high. So the width tolerance, I guess this is for the key itself. This is for the key seat. So I can apply this kind of to the keyway and the key seat as one, because they don't really break that difference up, right? They call them both key seats. So when they're talking about the width, they don't have to make two different columns for the shaft or the hub. They just make it like, hey, the key seat width, whether it's applying to both the shaft and the hub. And this other column is the key itself. So, which we're not even drawing the key, so we don't really have to worry about this, but we need to pick up the key seat and the keyway tolerance, and they're both combined there. And so my next column here is the width tolerance key seat. And I could say the width tolerance key seat and keyway, or I could say both. Because this is the key seat width. Okay. It's the same for both, but it's that plus 2 thousandths and minus that. So that just means copy this over here. It's the same for the 1/4-inch key and the 1/2-inch key. And that's something that's not shown here, but if they did, it would be like another variable. They're showing the width here. And what they're telling you is like the width of that key seat and keyway can be oversized by 2 thousandths, but it can't be any undersize. So they're allowing me the width to vary by 2 thousandths. That will allow the key to fit in there. So that's like a wider width than it is, and it can't be any less than the key, which is a 1/2-inch key. The interesting thing is the machinist can kind of help us out a little bit because they can say, well, when I build my key width and my key depth, if I'm actually like the machinist might build the key as well, they can take and make the key 2 thousandths smaller than 1/2-inch in both the depth and width. So I can get some tolerance there too. Like when I make that key, it can be 2 thousandths less than 1/2-inch. That'll help it fit in there too. But anyway, it can cause for some sloppy fits though. Like class 1, it kind of gave us this disclaimer that they could be a little bit of a loose fit because if you hit the least material condition of the key and I don't know, and all the least material conditions, or I should say anyway, I don't know, you hit all your clearances at their smallest size, you could end up with kind of a sloppy fitting relationship, like a loose key and a loose seat and a loose hub and everything's just a little bit loose. What it'll do is it'll wear parts faster is what it'll do. The key itself might wear fast. Like it would still work, but it could be causing life loss, how long it should last. So what it wants to do is this is the key width, which I'm really thinking of the seat and the keyway, how much they can vary. Just they can be like wider by 2 thousandths. So if I look at that, I'm going to make them 0.25, and they can't be any underside. So it's not 0.25, sorry, it's 0.5. Our key has to fit into a slot that's 0.5 because our key is a 1/2-inch wide. So it has to, our key seat and keyway have to at least be 0.5-inch, but they could be a little bit wider than that too by 2 thousandths added to that, which would look like 0.502. That's how I would get it. And then my half-inch key would fit in there pretty easily because it's just, it can be a little bit oversized. Okay, we have the dimensions to draw. Let's draw. So I have CAD open. I gotta open a new inch template to start this thing from scratch, right? I'm gonna put all these on one. So I'm ready to do this though. I know we're getting short on time a little bit. I'm gonna keep this as one video though. Try to at least do these drawings and call it a day probably, and then we'll finish the other two. One. I'm just gonna try to finish the hub and key drawing. So I'm gonna pull up my inch template, ISU inch template. Start from scratch right here. Anywhere in here. So I think what I kind of have to know is just some of this, all this data from this worksheet. So in order to draw this first, I can just draw the hub. So I've given you a hub OD because you got to kind of have a hub ID and OD. And I think I just made this up. There's nothing talking about the hub OD here. I think, in fact, they don't even tell me here on this what that was. So I gave that to you. So the first thing I can do is just draw two circles, and I can draw shafts. I can just draw the at least, and then we'll talk about cutting in the key here, keyway and the key. So let's just draw those first. So I've got I'm gonna pull my worksheet over to the other page, immediately the pull my worksheet over so I can see what I write. So on my visible object layer, yes, I'm gonna do a circle for the hub. I'll just draw it right here as anywhere. The hub OD is 3.5 inches. Yep. Oh, wait. I did it by diameter. So it's a 3.5 inch diameter. So if you draw it wrong and you have your properties panel up, I change mine right here, 3.5. Bam. That's a quick change. I'm drawing the hub and key. So what I'm really drawing right now are these two drawings right here. Because all the data I just pulled is for these two drawings right here. So I'll kind of draw them at the same time. So I'm just doing in their blank sizes. Then I gotta like put in the dimension for the keyway and key seat here. Yeah, exactly. So that's the outer diameter, and then the inner diameter, and I'm pulling this, these are just on your chart. These are these first given dimensions right here. So the hub inside diameter is 2.25. So that's what I'm going to use here. Which if you want to do that by diameter, that's maybe easier in this case. Concentric to that. So 2.25. So that's what my hub would look like, my collar. I don't know how deep it is or whatever, but that's what the shaft is going to slide into and be locked together with a key. So I'm going to have to cut a key way in that. Okay, that's great. Let's do I'll draw right here below it. Pretty much I will do it orthographically aligned. Another circle with the diameter of the shaft diameter matches the hub diameter kind of nominal size. So I'm just going to target here and project down here and maybe draw this in as 2.25. I could have copied that other one too, but I've got them orthographically aligned. That's fine. I haven't done any construction work, but I do have the centers lined up. No particular space apart, just enough. I'm gonna have to do some dimensions here. And so if I have to move them, I could move them, but yeah. 3.25 or 3.5 is what I put. Just kind of a random. Yeah, at least I put it on the chart. It's on my chart, but it's of no particular, just something so I have something to draw. And then I think I'm going to draw some center lines on this. I mean, I could use a center mark right off the bat to have something to work off of. So I might come in here and just put a center mark on these. Because what we want to do is we want to draw this in here. And usually I will, so the way, like, okay, so if I think I'm going to draw this in, and you're thinking like, well, how do I draw that in? Because technically what you have going on, like if I'm going to draw this key in here, this keyway in here, is I've got kind of a variance that it can be, right? Like my chart is telling me that it can vary that size. So what do you pick to draw with? Well, that's a kind of a question you got to ask yourself. Like, how do you know if I'm allowing that to vary, what do I use to draw? And I'm like, well, you technically, it kind of goes down to like, well, you can just draw with any of the size, and then you just got to tolerance it correct. And so if you draw it, to its small size, then you've got to make sure that you dimension it, small to big. And if you draw it to the big size, then you got to dimension it that it can be smaller. So you just got to kind of think of the tolerance. Sometimes I will just draw them to their nominal sizes. And then like the keyway and key hub, we think of it as being like it's for a 1/2 inch key. We determine that like it needs a 1/2 inch key for the size of shaft. That shaft diameter is driving that key size because it's a 2¼ inch shaft. It has to have a 1/2 inch key. So 1/2 inch is what I would consider the nominal size of the key. So I feel like maybe as my a good like to start this concept first is maybe just draw the nominal size in and then tolerance it off the nominal size. It's not like you have to draw it both sizes or the all you don't draw it all the sizes it could be. You just pick a size and draw it. And I think I'll base it off the nominal size. So I feel like what that means is this this has to fit like a 1/2 inch key in here. So I might do some construction work. Oh, I don't know. Like this is I probably drew this differently on another video because it's just however I think about it today. I'm just going to put in a construction line maybe through here like this. This is through center because what I want to do is I want to put in that key the keyway, maybe the width first is what I'll think about. Like how wide is that? Well, it's a 1/2 inch key that's going to fit in here. So I feel like I can offset this line by a 1/4 inch, and that'll be a 1/2 inch wide keyway. So if I say I'm gonna offset this by 0.25, this construction line that I just did. Well, then that's the key, that's the nominal key width. It's a 1/2 inch width, right? And this is going to be chopped into here at some particular depth chopped in. So that's at least that. I know that. Interesting thing is off my given data here, this is where this like I almost started with my dimensions off the bottom a little bit, but I put in the key width first, the keyway width, and it's going to be able to vary this. Yes, I drew it so that's a 1/2 inch wide, but when I tolerance it or dimension it, I'm going to say that it could be down to this size as well. So I'm going to actually just allow this or maybe even build a dimension style to tolerance this. But essentially, I'm drawing it its nominal size. It can be oversized by 2 thousandths. So, okay. But I've drawn it at 0.5. I've offset it. So let's figure out what the depth can be. And I'm just looking at, so I've got this one drawn in. So the depth is going to be this, I think they call it T. The T max dimension right here is this 2.477. So I think I'm going to put this in as kind of a nominal size, right? This is kind of a nominal. This T max dimension is 2.477. And so it can be that, and then it can be, and then the tolerance I'm going to have to apply is this. It's going to have these dimensions that I will allow it to actually be. But I think I'm just going to put in this as the nominal size, 2.477. I just have to know where that's pulled from. This thing shows that the T size was from bottom of this. So I could draw a line that's horizontal with the bottom of my inside diameter and then just offset it, this T max dimension, 2.477. That might be what I do is I come back over here and say, if I had a construction line, right? I just draw any construction lines I need. If I had this construction line that was kind of just truly horizontal with like I just drawn it across it. It's of no particular length. I just drew it kind of across my part here. So the T max dimension is given, and that's going to be the depth here of my keyway. I need to offset this line by 2.477, and that would be the T max dimension. Let's do that. So I'm going to offset this thing. This line that I drew perfectly horizontal, tangent to the bottom, 6 o'clock position of my inner bore. So I say it's 2.477 was the T max, right? So if I offset that, there is kind of the nominal distance that it could be, like the max cutout I could be. So I could trace this now. Now I have kind of a profile of the keyway that it would be. So if I go over to my visible line work, then I feel like I can trace that it'd be cut in here, it'd be cut to there, cut across, and then cut down. And then this would be trimmed out. So this is now, I've just like machined that out. So now I can accept a accept a key into my keyway there. I have to worry about the dimensioning and tolerancing once I actually apply dimensions. Right now, I just got it kind of modeled at kind of a nominal size, right? So it's modeled at nominal. Let's do I need to do the modeling for the key seat in that. And so it's the same width, the width, by that table 4 chart, the columns for the key seat, we're kind of including the key or the widths essentially. We're kind of including both the hub and the shaft in one. And so I think it was just yeah, so I can really do kind of the same little construction work here. So I think I'll probably draw a little construction line here. I'm going to offset that for the nominal key width, which is 0.25 if I'm an offsetting for a 1/2 inch key. So there's my nominal key width for my key seat. And now I need to know that S dimension, that S max, because ASME likes to dimension that from kind of this point of tangency out here on the shaft to the kind of the depth of the key seat being cut into this. And so I'm probably going to draw another line like I did. It's going to be based off of this. And this is just kind of ASME. It makes it so you can draw this pretty easy and it follows I like that the ASME way I'm going to dimension this is kind of how the machinery's handbook shows how the machinist how to cut it, right? That's that the lines of communication are the same if I'm following an ASME standard way to notate and annotate a keyway and key seat. It's going to match that machinery's handbook that they're going to use to check my work. So there's this kind of like uniform system of like me dimensioning this way, they are cutting that way. It's a good situation. So I need to find what that S dimension is though. S dimension. You were given a nominal size for S, right? At 1.972. So I think I'm going to draw that to the nominal size. So I'm going to offset that last line I just drew by 1.972. So I got that here. And offset this 1.972. And then drop that in. So there's kind of like the nominal size of what the key seat would be cut out. So I can trace that over. Yeah, I did 1.972 or which way? This way? What you tell me? It's just the nominal size of the key. What is that? That's half of it. Nominal size of the key is 1/2 inch. So yes, I offset it by 0.25. That way I get a 1/2 inch. And then I've offset that by my S. Now I'm going to trim this out. And I'm ready to dimension this. I can actually put the hey, oh, cool. So I'm gonna turn off my construction mode. So I'm gonna go into my sheets. I'm gonna do this on these sections. I think I'm able to. I don't know if I finish this at a 1-to-1 or if I probably not. It looks a little bit big for 1-to-1. Yeah, I could have fit them better if I wouldn't have done them top to bottom. True that. Yeah. 1/2 inch. It's a half scale. Yeah, this will be fine for right now. I can determine if I might. Yeah, I won't totally set myself on a scale until I finish my other ones, maybe. And then I'll decide if I need multiple viewports and if I need multiple scales, I can apply those too. So I'm not gonna worry. I'm at a half scale right now and it fits on my sheet. So I'll just lock it at a half scale for the moment and not worry too much about it. But let me go into I just wanted something so I could start dimensioning. So there's a couple things to dimension because I don't have a rectangular view. I'll dimension my nominal diameters here. So I think the first thing for me to start with will be some diameters. So I'm gonna dimension this as a diameter, and it's not any that's just something that was given on my sheet. It's a 3.5 inch diameter outer bore hub. It's kind of a nominal or basic size. I wouldn't know I don't really know what that is for sure. I mean, I just know it's that diameter. So I'm not going to manipulate this dimension at all. And then I'm going to give, because I'm not doing a section view on here where I could give the inner bore size. So I'm going to do another diameter for this inner bore like this. That is a nominal size. We may change, and maybe I'll put this one above. It doesn't really matter, but I'm just kind of working with a little bit of staggering here. So even in the rectangle, even if I were to take a section view and pull that, I wouldn't get that dimension either because because the keyway that's cut in it, I wouldn't be able to actually pull this dimension. So this is a great place to at least put the nominal size in. In the future, we might start changing that dimension to like a basic dimension or something because it probably has some tolerances allowed to it. We didn't do any tolerancing for the actual shaft diameter or inner bore diameter, so it's just going to stay at 2.25. So I'll just leave that there. The other diameter I need, and I call it a diameter, even though it kind of breaks that rule of, well, it's not, it's only a partial. Why isn't this considered a radius? That's a good question because it isn't a full circle, but I do feel like it would be weird to dimension an inner bore for a shaft like a hub like this as a radius. It would be more common, even though it does have a break in it because of the keyway. I feel like I guess in we must break the rule a little bit as drafters and say, yeah, but it's a shaft diameter and a hub relationship. We wouldn't do that as a radius. So that's kind of a rule breaker, but it would be more common to see this on a print with a diameter sign, even with the breakage for the keyway. And it's going to be the same way here. I'm going to dimension this diameter. So that. So what it shows is, yeah, we have a size on size relationship, but really we're kind of nerding out over the keyway cut into it and the tolerancing there, and we're not nerding out over that, which would likely not fit together, actually, in all honesty. That's that. Yeah, I wouldn't even need a key. That would probably not even be able to get in there to fit because they're both the exact same size, and that's what I call as a size on size relationship. And if you ever do this and you're drawing stuff like that and you notice that, it's usually a no, 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 unless there's a tolerance applied. Because if you remember when my making a case for tolerances a couple weeks ago, I said when a size on size relationship fits, you probably have a 0% chance of parts fitting together good. I mean, you're force fitting them maybe, but until we'd have a tolerance applied to these two dimensions, they're not going to fit together. And then tolerances is going to take us about 70% there. And then we're going to get 100% a fit if we go into the GD&T land, really. But we'll wait for that for next semester. So we just kind of build on some concepts here. And all we're doing is now we're going to nerd out over the dimensions for the actual cutting of the key seat and keyway. And so let's see what we got. So ASME loves us to have like some, like if we think of how ASME likes us to I don't even need to really look at the tolerancing yet. I can just slap the nominal dimensions on here maybe and say I'm just in my ASME two decimal place, my standard little. I haven't changed any dimension style or anything, but I'm just going to do some normal linear dimensions here. And so if you can remember right, what ASME likes is it does like to know kind of what our chart says is a T dimension for the hub, but that's just from top to bottom. Like it likes to know what this dimension is. It's calling out 2.48 because I'm a two decimal place dimension. Red flag should already be going off in my head because technically this is given to 3 dimensions. So I would not want to leave mine at 2 dimensions because I'm now decreasing accuracy. So at first, but I don't need to worry about that yet because I've got some other things going on with this dimension I got to worry about. But for sure, 2 decimal places is insufficient to carry the degree of accuracy from my chart. So I'm not going to round it off as a drafter. So I've got to change that, but for sure ASME likes this. And of course I can pull this back to the object edge. Pull your extension lines back. It likes to know kind of this overall T dimension. And then it likes to know, and there is some sense in me to say that it's like the most correct to say that that's size. And this is kind of locating because if I think of that always going back to that size and location relationship that yes, this is a size, but this is the location off the center line, right? Like, um, and so I like this as a locating dimension for this size. So I kind of I size this, but yes, I'm locating from center to there, and then I'm pulling, kind of following this maze, right? This dimension is now based off kind of a center line, is how I view that. And it's the same way when we get to this key width here too, right? Like we'll think like, well, I want to know this size. This is the size of the keyway, right? So it's a 1/2 inch, but that's just kind of based off what? Well, I can locate it by saying, well, it's based off this. It's like from center to center here, right? Is a location for that size. This does the same thing. I'm locating off the vertical and horizontal center lines, quarter inch over, and then it's a half inch. So like ASME likes this. This is kind of the way it would like us to dimension ours. But now that's we have like we need to be a little more critical with our dimensions because we have a tolerance applied. So let's apply them and see now. So the tolerance really applies to the key width and the overall like what they call this the T dimension. And so if I just go to my chart here now, I need to consider the tolerances. What would he say? Consider the following. Exactly. Yeah, so my dimension really needs to be for so I'm only looking at the hub T max dimension, right? Hub T. I'm saying that hub T with the tolerance applied could be 2.487 to 2.477. So really it's saying that it can be 10 thousandths. Is that right? It's another thing. Be 10 thousandths more and none less. So I could build a dimension style, and it's three decimal places of that. So I could kind of build a dimension style with this tolerance already applied into it because what we end up doing is we're gonna kind of dimension this as a limit dimension. I think what I've done is instead of doing a dimension, and so I have a couple ways to apply a dimension on my sheet. If I look at the way I did it in my example, I'll just zoom in on this. And you guys remember this from your dimension chapters that you talked about. What I'm displaying here is kind of it's a limits style dimension. It means it's a dimension where the tolerance has been applied. And so now what I display as a drafter are the limits of the dimension. So it has like a 10 thousandths uh, tolerance applied that it can be bigger than the dimension the nominal size that I drew it to. And so the other way I could dimension this would be to leave the nominal size and then have a plus or minus next to it, right? That would be like a nominal size dimension with a tolerance plus or minus dimension right next to it. That's a totally appropriate dimension style too. So I could kind of build two different dimension styles here. Um, and so let's go into our dimension styles and explore how can I get this to display maybe this way, knowing that that's what's going on, knowing that I've drawn it at nominal size, but it can be it can be larger by 10,000. So let me go back to CAD. Let me think about this dimension. And maybe I'm going to manipulate the current one. So what I want to do is like, let's go into my dimension styles, which is either like go here and go to it, dimension styles, or I always go to it right. And then we haven't explored this too much, but we have some tolerance ones already built in here. I can't remember what specific assignment. I don't know if it's this one. We could look, but maybe I'll just start from scratch and ignore these ones that have already been built because they may or may not be what I need anyway. So I'm going to start with this one and I'm going to say, maybe I'm going to create a new one. And whichever one I have highlighted is going to base off of, right? Say a new one based from this. And I'm going to say, yeah, it's going to be like, oh, I don't know what to call it. It's going to be an ASME. It's going to be three decimal because I know I need three decimals. And maybe it's going to be just for the hub itself because I don't know if I don't know if I'm going to be able to use the hub one for the shaft one. Probably not. So I'll just say like hub if it helps us just to have like some indicator. This is a three decimal place for the hub, just some unique name. I'm going to make it annotated. So I'm going to say continue. And the only thing I'm really going to change here is nothing in general other than maybe its accuracy for one. And so let's find out, let's remind ourselves where accuracy is. It's probably in primary units. Decimal precision, I want to be three decimal places. So this one I'm changing to three decimal place on the primary units tab. That's one change. And then alternate units, we're not displaying any alternate units yet. That'd be like millimeters on an inch template or something. So we're gonna do tolerances now here. Okay, cool. Tolerances. So let's see how this works and see what options I have. So I don't think we've messed with this tab yet. So if I say on the tolerance tab, what do I have? Oh, I can either choose like if I choose these, it's kind of interesting to see. Mine's a little bit blurry. If I make this bigger, it clears it up. I don't know if it does or not. That's pretty nat. Geez, their viewport could be this is a symmetrical tolerance. which should be plus or minus with the same symmetrical tolerance means I don't have to do like multiple, um, my tolerances are the same in both directions, symmetrical. So it can go the same plus or the same minus. My tolerance is actually not that way, right? Like my hub T tolerance was kind of like, yes, bigger, but none less. So it's not a symmetrical tolerance. So I'm not going to use this one. Then we have a deviation, which was mine could be displayed this way. I could have the nominal one displayed, and then I could go ahead and apply the two tolerances, the plus and the minus that are not the same, right? Which would be, so this one would work for me. And this would be a legit way to dimension mine and include the tolerances. So that's called a deviation type in CAD. And then we have limits, which is what I'm going to do. So I'm going to actually apply the tolerance through here, and it's going to just display the limit type dimension. But I feel like this one or the deviation type are appropriate dimensioning. And then what's the last one is a basic. A basic is going to be kind of what I could call, I could call my nominal like the hub ID and the shaft OD. I could kind of call those basic dimensions that should have a tolerance applied to them, but which puts a box around them. So we call a basic dimension, and that really gets specific when we get into GD and T land. That I really like am careful to like make sure the dimensions that are basic are boxed like this for GD and T. But for right now, we can be a little lazier and we're not talking too much crazy about basic dimensions. So I'm going to just say that I'm going to make a limits type dimension style. And the upper, so this is what you have control over now is kind of the upper, like the plus and the minus. And so if I look at my worksheet here, I'm going to build this particular dimension, and I want these to display for my hub. Then this is my hub allowed variation here. Can be plus 10 thousandths, but minus none. And so I feel like this is the upper deviation and this is the lower deviation. And maybe that's confusing. And if I get it wrong, it's just a matter of reversing the tolerance dimension that I'm applying. So I'm paying attention to it when I apply this tolerance, I'll just pay attention to the dimension and how it changes and see if I need to change my tolerances. So you just got to kind of, if you pick wrong, it's all right. Just pick the reverse. But I'm saying that my hub should be plus 10 thousandths and minus none. So if I go over to this, the upper value, I think I can go up 10 thousandths like that. And my lower value is minus none. So I'm going to leave that. So I've just changed this to display 10 thousandths. You can type this in here too. I think you can put 0.1. 0 10 thousandths. Did I do that one correct? Maybe 15 thousandths. Because it's up 10 thousandths, right? Oh, is that? I don't know. Yeah. Let me see how I wrote it here in my chart here. Sorry. Yeah, 010 is what I want to write, and thousand. So this should be 0.010. Will that accept that? Let me delete all that other stuff. I think it should accept this. Yeah. 10 thousandths. Lower value, none. I can't be any smaller. I'm not doing any other thing. Okay. Let's just say okay on this. I'm not really setting it to be I'm still going to keep this one as my set current. But what I've done is I've built that dimension style. It's in my list now. So I'm going to close this. So now, remember, you can just push this to a new, I don't want it to affect my whole drawing. A lot of this is dimensioned correctly. It's just that this one is not displaying correctly. So if I select it, single select it and right click, you can push this to a new dimension style, just like local, like this is just like me locally pushing it. Single selection. If you double click, obviously you're in there like manually manipulating dimension, and do not do that. Never manually manipulate the dimensions. That is, I mean, that's a really easy habit to get into, but horrible for the next person to work with your drawings. And they don't know that you manually change the dimension. Oh my gosh. What a needle in a haystack to find that is. And then you want to punch whoever did it. So don't do that. If it's not drawn, if it doesn't display the right dimension, you have to fix your drawing. Okay. So single selection, right click, dimension style, push it to 3, the one I just created, and decide if that's reading right, then that means I put my tolerances in correct. And how I would check that is go back to it should be, can be 487, but can't be any less than 477. So let's look here. 487 to 477. So I put my tolerances in correctly so that my limit dimension is displaying these dimension. I've actually drawn it to the nominal value. Usually if I have like a anyway, I won't get into detail too much here. We did good here. It was great to just draw with the nominal size, right? So it kind of depends on if I have like a symmetrical tolerance or I have like a deviation type tolerance. Sometimes that impacts the way the size that I model to, right? Like if I have a symmetrical tolerance, I might try to draw to the middle of the tolerance or something, or I might still put in the nominal tolerance or draw to the nominal size and have a deviation. But anyway, just be careful. Yes, you should be careful. The way you draw sometimes does impact how your tolerances will work and display. So I like this though. I think that's kind of I haven't done I just need to do the tolerance for the width here. And then maybe do just a little bit of cleanup here. But this is the main one I have to tolerance. This is just a location. Um, I could be concerned that this isn't located exactly tolerance. Like there might be an argument that I should hold this to three places if this is to three places. I can leave. I don't know what I did on my example. If I may not have even included that. It's kind of me thinking a little more critically. Like that is a location dimension. I'm going to keep mine on there at just two decimal places, but sometimes I have to wonder if this makes sense to the whole overall. Because if this is not held to the same tolerance as what I'm basing my tolerance from, then I could have some inaccuracy that I wasn't expecting. If I located with this and it's not to the same degree of tolerance or accuracy, there could be an issue with my parts. So be careful. If I do apply some location dimensions, I may have to be careful. If you don't see what I'm talking about, that's okay. Don't worry about me. Just keep drawing. And then this is the one I need to tolerance. So this is a nominal dimension, but really my chart says that this thing is can be 2 thousandths over. So I'm going to go ahead and make one more, probably make a copy of my one that I just made, but it's just going to be for the key. Maybe I'll call it for width or something, right? So I'm going to do that right now. I'm going to go back to my dimension styles. I'm going to start with this one, the one we just made. I'm going to do like a new one. Maybe I'm going to call it, oh yeah, I just got to call it a different thing, something, delete. It's not for the hub though for this one. This is actually a three decimal style, everything the same. I kind of want it, but I want it to be for maybe the width. It's not real clear. If I had like 40 different dimension styles, I might need to be a little more specific on that, like key width or something, like half-inch key width or something. But this will be fine for our level of drawing. Just something that I can pull out of the hat or pull out of the list. So I'm going to say, yeah, continue that. It's pretty much all the same, except for the tolerances are not, it's not 10 thousandths if I look at my chart here. So the tolerances aren't the same for the key width. They are only 2 thousandths. It can be plus 2 thousandths, but minus none. And so I'm going to go back here and say the upper value cannot be 10 thousandths. It has to be 2 thousandths to none. And I'm going to say, okay. I'm going to still keep this one as my set current and close it, but I'm going to push this one now to that style with the width. And so it's a 502 to 5, and it's out to three decimal places. I'm keeping both of those to three decimal places because of that. This is inches, so I could drop the leading zero. I feel like one thing that's incorrect here is that inches, I'd probably drop the leading zero. So it's funny, like for whatever reason, I'm going to go back in and modify that width dimension style. I'm going to modify it. It's just because ASME, we would drop the leading zero. So primary units is three decimal places. Leading zero, suppression, it does say zero. Let me see why I'm still getting a zero there.
It might be because it's separated and like a little separate.
Yeah, this may be, so I need to suppress the leading zeros. Good call. Yes, 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 yes. Excellent. On the tolerance tab itself, I would suppress the leading zeros. Probably could fix my other style that way too, because and I think I probably will. I'll go back into the hub one, into modify, just to make sure if I ever used it for something like this, that I would be suppressing those leading zeros, leading zero suppression. Okay, close it. And that's better. That's, yeah, now I don't mistake that for like a metric dimension. That looks better. So then it's just a matter of cleaning up that. I think I've got the dimensions for this view taken care of, maybe. Just need to do my spacing. And now this is a little bit bigger, so I don't feel like, a quarter inch away from here is not going to be sufficient. They're going to overlap. They might work if I went over here, but I think I'm just going to break this rule and be like, well, I'm just going to put it above, something like this, separated enough that I don't bash into these, and I don't, this is great. This will work. It's breaking that rule, but it's for clarity's sake, and that's key. Yeah. So I'll push this one 3/8 of an inch away. And then this one might, but I feel like still it will even be too crunched in there. So I'm just going to break that rule and pull it away. I'm going to try to get my lines on the inside. Something like this will work for me. And now I'm ready to finish this one off. Then we'll be done. I know this has been a kind of a long-winded finish. These are kind of, but what ASME wants me to do is, at least it wants me to have this dimension. This is called S on the drawing, right? That one is critical. I'm kind of adding this one as a location dimension. Which is probably maybe a bit of an upgrade or update from my other. I'm going to pull this back to the object edge as well. And then I need my widths. So I'll locate those the same way. I need my overall width. And then I'm going to dimension from there. And then just apply these tolerances. They're different though, right? Because they of course they're different. We could just have them the same. I'll look at what that S dimension was. S was on my shaft. The S dimension, that's how I drew it, 0.1972, but the S tolerance is going to display like this. So the shaft key seat is this. So it's a tolerance kind of the opposite way. It's like can be no bigger, but it can be undersized, which would be a deeper cut in the shaft actually, by 15 thousandths. So let's do that. So I'm going to go back there and make that dimension style. So what I'm going to do is go to my dimension styles. I'm going to start with the hub one again. I'm going to make a new one based off the hub. It's going to be shaft. I'm just going to delete this. Let's call it shaft. It's got a different set of tolerances. So I'll say continue. I'm going to pull it out to 3 decimals as well. Let me double check my chart. I think I'm holding this to 3 decimal places. Yep, that makes sense. So keep it 3, say continue. The only thing I'm going to change is the tolerancing again. So tolerancing, the upper value just has to be 0. This one can be smaller than though by 15 thousandths, right? So I'm just going to change this to be 15 thousandths here. Lower value 15, zero suppression is on for the leading zeros. I'm going to say okay. Close it. I'm not going to set it to but I'm going to change this one, push it to that dimension style for the shaft. So, and then I'll just double check. Is my shaft reading 1.972 to 1.957 according to my planned worksheet? 1.972 to 1.957. So that is dimensioned correctly there. Keep this location dimensions in the slide. Yep, this allows someone to cut this at least that big, and then it can be undersized a little bit too. That'll allow some extra room for the key. This one, I'm going to be allowed to apply the same dimension style. So that's cool. It matched both the upper and lower. So all I have to do is select that one and go for that width, 3 decimal place dimension. And that one's done. That was quicker. Just a little bit of an alignment thing. And I think that really is the first time we've really applied a tolerance to an actual drawing, right? I think so. I think this is the very first time, which seems like a long ways to be doing tolerances 12 weeks in, but it's true. That's about, I mean, that's what takes a little while to get there. I'll leave those. I know they're stacked. That's okay. As long as they're not too close. I wouldn't want to get those any closer, so I'd want to pull them away. Hold it. I could pull that one over here. You know, you're always looking for like clarity, right? Maybe this is more clear. I think that's fantastic. So I'm going to bounce back out here. It's a good start to our drawing. I better save this thing wherever I'm saving that stuff back in week 12 or now in week 12. Oh, this is week 11 stuff, so I'll save it week 11. That's it, you guys. Tomorrow we'll finish the other two. I know we will, but it might take us a little bit. Maybe we'll barely get into week 12 stuff probably towards the end of tomorrow, and but definitely look for that base mount drawing, see if you got it, and then we'll be ready to jump into the new stuff. But yeah, we still got some wrap up to do. I like the next drawings though. I like them. I mean, I like the one that's got an actual assembly with the fastener going into a blind hole. That's a good one. So anyway, let's wrap this up.